Okay. Um, Hello, everyone. Thanks for coming to the Envoy deep dive session. In this talk, I'm going to give a talk about Envoy and its extension system. My name is Lizan Zhou. I'm one of the maintainers. We have my colleague D from Tetrate as well. He will be able to answer questions from you guys. So I will spend approximately 15 to 20 minutes to go through the talk and have the rest of time for the questions from you. Okay. Okay, so yeah, here's today's agenda. I will go through, roughly go through what Envoy is and Envoy design goals and about the extension and how it operates inside the Envoy architecture. So before going into that, anyone here runs Envoy in any places? Okay. Have any one of you used Envoy extensions? Oh, have anyone actually writes your own Envoy extensions? Oh, wow, nice. Okay, so just briefly going through, Envoy is the service proxy that handles the most of the networking features for the application. So the principle here is the network should be transparent to the application, the service behind Envoy. And Envoy will take care of most of the networking features like authentication, authorization, monitoring stats, retry, and etc. And the configuration is Envoy configuration is managed by the control planes. So yeah, this is like the deployment model, like in the service mesh. You deploy the sidecar proxy for each services, and the services is communicating to each other through the service proxy, which is Envoy. So yeah, I will go quickly through this. Oops. So Envoy design goals mainly consist of the listed up here. So basically the features are implemented out of process. Out of process means out of your application process, so it can be managed independently. The L3 and L4 filter architecture I will be talk about later, how to extend that. Basically the L3, L4 filter, you can implement many TCP-based protocols. Now, and on the L7 filters, you can operate the HTTP filters to do much more rich feature set on that. So Envoy designed as HTTP2 first, so it can support protocols based on HTTP2 like gRPC. So it does support them as well. The configuration API, I think many of you may already know. The configuration API can allow you to manage the multiple Envoy instances from the central management server, which is the unique, which one is one of the unique features that Envoy has compared to other proxies. And also Envoy have the best-in-class observability features like the stats, logging, stuff. So here one of the key features is the Envoy extensibility. This is the internal design diagram of Envoy. If you see we have workers which is spawned during Envoy startup. And the XDS API is managing how those are constructed. Those managers are independent from the request workflow. So basically, the if a request coming in, it's going through the listener filters and go to connection filter chains, go to L3, L4, go to L3, L4 filters, and if that is a protocol that Envoy can operate at L7 layer, like HTTP is one of the most common case, then the HTTP connection manager will take that each request, which is not necessarily bound to each connection. In terms of HTTP2, you may have multiple requests associated to one connection. That each request go to the HTTP filters and goes to routers finally, and then go to the backend services. Same apply to the, so the vice versa applies to the response. It comes from backend services, go to the right filters, and go to the codec through and going through the listener to the downstream clients. The filters can do very powerful stuff. It can modify any of the data at L4 and L4 layer. It also, the L7, in terms of HTTP, it can modify the headers, modify the data, also modify the trailers if the, in the case of the HTTP2. So that allows us to do like transcoding, gzip compression, or anything in this layer as well. So we have this much of the point of extension point. So the most common case is obviously the L4, L7 filters. We also have the access loggers, tracers, health checkers. Transport sockets is the mechanism to handle the TLS, which you can also extend that to handle anything else. The existing, other existing feature for the transport socket is the tab, which allow you to basically do something like the traffic socket capture. So basically allow you to capture the packets to inspect what's going on through Envoy. And also retry policy and resource monitor and stat things are also extensible. So here is like the screenshot I took this morning from the Envoy source repos extension. You can see it is updated pretty frequently, and that's the extensions that we have. I cannot list up all of them since we already have tens of extensions here. So what is new extensions? Like the recently new introduced extensions are, one of them is the TAP, is the basically the socket capture feature, allow you to capture either at L4 or L7 layer to debug your traffic going through Envoy. It can be controlled from the admin endpoint. So basically, you can say you can open a request to admin endpoint. Say I want to see traffic matches this and these conditions, and get a sample of the traffic from the admin endpoint. MySQL and Kafka and Dobo is the 3 new L4 filters introduced in last half year, which basically adds additional support for those protocols, so you can operate them at L7 layer. That gives you those protocol specific stats, and routing is not completely done for those projects, for those filters, but that will be, because Envoy is already parsing those protocols, that could be done in next couple months. So the next is like how to write your extension. Basically, here I'm just talking about the C++ extension. The C++ extension, I think small amount of you already have some experience with this. So basically, each extension comes with two parts. One part is the config part, and one is the real implementation. The config part is hooked into the Envoy config parsing process. So that tells Envoy that this name belongs to this extension, and the Envoy will take the configuration to initiate your extension with the implementation. So usually the configuration is the protocol buffers. So like you have some authentication service filter, you can specify the this one is your own defined one, and that one you need to register the config via the C++ static registration factory to register to Envoy, so Envoy knows how to initiate the filters that you wrote. And that here's the example, since it is simple enough. This is a gzip filter. Basically, it allows compress the response Envoy received from backend service and compress sent to the downstream. So the config is just like this. You create the config from the protobuf, and this is the logic. Here I only show you one of the methods from the filter, which is encode data, which is the most, which is a key part of the filter. It just needs to do send the buffer to the compressor. So then the data is modified by the compressor, and it will send back to downstream. The skip compression Boolean here is compressed by the header to see, you can do your own logic there to see if the client can receive the compressed data, and or put another conditions there to calculate that variable. So there's also some other ways to extend. I think one of the existing one is the Lua filter that allows, which is only operated on HTTP now. That one, you can write a Lua script in your, basically the Envoy config. You can embed the Lua script into Envoy config. That Lua filter will take the script with LuaJIT compiler, and that will allow you to do the header and data modification as well. And also we are having WebAssembly work ongoing in a separate repo. There was a talk by Dee and John on Tuesday about the WebAssembly. And also there's a proposal to do out-of-process extension via gRPC, but we are still evaluating those options as well. Yep, and that's how the extension now we can do. So yeah, that's basically what I have today. So we have, I want to thank you for adopting Envoy, and we have very great community. If you have any question, just raise your hand, and from now on, I and Dee may answer your questions.
So basic, it's a basic question about the extension model.
Yeah.
So these extensions you're writing, these additional filters, are they compiled with Envoy? Do we have to do extra builds, or is it a binary plugin system? So how do I add these extensions to an Envoy instance, for example?
So currently the model to build Envoy extension is you pull the whole Envoy repo into via Bazel to your extensions, and you build a fully static binary from the Envoy upstream source and your extension. Currently, we don't support any dynamic link modules. I think one exception is we do support the open tracing dynamically link library for the tracers. That's the only one. Since we don't have a fully stable C++ API, we don't have the ABI stability either. So that makes the dynamically linked library extension very hard as current situation. So currently the way is doing static link from all the upstream and your extension together. So you'd have to build your own binary. Yeah, yeah. I would expect WASM will solve this in some factor, maybe D can answer, since WASM allow you to dynamically load the WASM modules, but that is not currently supported.
Okay, so, okay, so before we continue, basically here we have Lizan, me, and we have Rama here from Salesforce. He's a major contributor for Envoy, mostly on stats, right? So if you have a specific question on stats, because observability is one of the key features of Envoy, probably Rama can help you, and he can also tell you about his experience on deploying Envoy in production on scale like Salesforce, right? Okay. So basically right now, probably you can quickly tell about that.
Yeah. So from Salesforce perspective, we've been deploying Envoy at scale since last 1 year. So we've been running service mesh with some other proxy, and as soon as XDS APIs came into picture, we latched onto that and we built our own control plane and deployed the control plane at scale, and we run more than 5K envoys in all our data centers, and they serve critical core traffic basically.
Yeah. All right. Any other questions?
So you mentioned that you set up your own control plane. Can you just talk about some of the challenges you hit with that, and if you'd recommend it?
Yeah. So if you look back, right, if you start from today, I would say maybe we should look at Istio because it's matured a lot. But when we started 1.5 years back, Istio was just coming up. It's not as matured as now and as production ready as now. So we decided to build our own control plane, and then we have our own internal discovery system, which Istio, it was very difficult to integrate with Istio. So that is one another reason we built our own control plane. But now, if you are looking to start afresh, I would suggest to look at Istio basically.
I apologize if you covered this already. I've heard that Rust can support the C++ ABI. So have you heard of anyone writing extensions in Rust?
I'm not aware of any the Rust extension currently.
Okay.
I guess the harder part for is maybe for the build, and we don't even like Rust can support the C++ ABI. Probably putting them together is a little bit hard right now. Since we don't, as I mentioned before, we don't have the ABI or API, even API stability for the extensions yet. That is one of the reasons that it becomes hard.
Thanks for the brisk jog over here. Is there any plans to support dynamic loading of modules?
Dynamic loading what?
Of the extension modules?
Yeah, I think we are happy to support that as a project, but there are some difficulties to support that. As I said, the API stability and ABI stability. Basically, we want to move fast to evolve Envoy itself, and that guarantees some sort of like ABI or API stability for extension will be a maintenance will add some maintenance cost for us. But we are looking at it, and we have the issue to track that as well.
Thanks.
Any other questions? Anything about Envoy is fine, not just about extensions or, yeah. Other questions? Okay, so I think I can wrap up here. Thank you everyone for coming. If you want to talk to us, just come to the stage after the talk. Thank you everyone.
Thank you.